Hey, what's up guys? I'm back again with more Blast Project updates. I know it's been a while since my last video. I've been hard at work on the game and hadn't felt like diverting my attention to content creation. But I'm here now and I wanted to talk about the new camera system I've created for the game and even get into the code a little bit and break down a little bit of how it works. So yeah, let's get started. So here's an example of a basic camera system. In this kind of system, the camera just blindly follows the player wherever they go. As you can see, it shows the bottom of the level, it shows past the end of the level. The level doesn't really feel like it's opening up as you play. You can just basically see everything. And I feel like this makes the game feel a lot less immersive. Obviously, like some of the issues like showing outside the edge, these can still be fixed with limits. But to really fix this, we need a sort of system in place that can instruct the camera what parts of the level it should show based on where you are. So I'll show how I kind of dealt with this next. So here's the old camera system. It's pretty simple. It just uses area 2Ds that when the player runs into them, it will basically instruct the camera to change its limits. You can see over here that I've given it like a special script with some export fields. So it's really primitive, but it was simple and it worked for a while. You basically just set the limit that you want: left limit, right limit, top limit, bottom limit. And I have a special case where if you use -1, it will just not update that limit. I also have one shot, which allows the trigger to essentially disappear once it's been activated in case we don't want to like reset the camera later on. We can also set like our follow target, so you can like when you run into a certain trigger, you can basically tell it we're going to follow this other target now instead of, you know, not necessarily the person that triggers it, which is going to be the player, and some stuff like that. So this system worked okay, and I can give a quick demonstration of what it looked like. So I'll just open this up and run the thing. Let's make it bigger, take off the enemy so we can just show it. So here's how it worked in practice. So we're here right now. We're restricted to this height of the screen. We don't want to go any higher than this. So we go over here, no matter how high I jump, the screen doesn't go above this. So we're still here, we can't get any higher than this. As soon as we touch this, now we have a higher limit. Now we can get all the way up here. And if we go over here, that limit doesn't change. There are some problems with this system though. So for example, if I come back over here, suddenly the limit just jumps back down. Now hold on a moment. Some of you who are more familiar with Godot might be thinking to yourselves, well, why not just turn on position smoothing and then everything works fine? But the problem is I don't like position smoothing. I don't like the way it looks. It makes the game look too modern. For that reason, I decided that implementing my own custom camera code made more sense. And actually, I realized this is kind of just a missing feature in Godot in general, and so I decided to make a PR to the main repo. We'll see if it gets accepted or not, but anyways, let's get back to the video. Some of that stuff was a little annoying to work with. Another issue I ran into, which eventually led me to just need to overhaul the entire camera system, was I wanted to add a room system into the game. And so like for example, right now this entire node, everything that's in here would have got shoved into a room. And so one of the things I wanted is that I could like take the whole room and like move it somewhere. So you move the whole room, and what I realized was that because these camera limits are like statically set in the editor, the camera limits didn't update with the room, and so I was thinking this would be really annoying to work with in the setting of like dragging rooms around, and I wanted something that would be a little more level editor, level designer friendly, which led me to creating the new camera system that we're using now. So here is the new solution that I came up with. I made a new version called Camera Bounds New, which I actually just need to rename, but I'll get to that eventually. So camera bounds new is a lot more intuitive to work with. I took I think it's a reference rect, and I basically just draw that rectangle onto the screen. And wherever that rectangle is defines the viewing area that the camera can see. And so it works really nice, and you can see here, like, I actually drew the rectangle really long. And that was just because I wanted to demonstrate the rooms, that when you kind of run here, you can see across, and then after you cross through, you can see that where you came from. But yeah, so you have these reference racks, and wherever the player is, whenever he enters one of these reference racks, the camera will take the union of every rec that you're in to determine what the limits of the camera are. So, like, for example, if we're just inside of this rectangle here, then the left limit will be this side, and the camera's top limit will be this, and the right will be this, and the bottom will be this. It's a little bit flawed because, like, if you have like a really, really tiny reference rec, then it can't be smaller than the screen, and so the camera just kind of gives it its best effort. And you can use these tiny reference recs too if you can set horizontal and vertical priorities. So if it's too small vertically, we can say, like, okay, well, prioritize the bottom. We don't want to show lower than that, but if it's higher than that, it's fine. And then same with left and right. If it's smaller than the screen width-wise, we can say, okay, well, it's okay if you can see farther than the right edge, but or it's okay if we can see farther than the right edge, but we don't want to show farther than the left edge, or, you know, vice versa. Or if you don't care and you just want the camera to figure it out, you can just use none. We have these offsets here, which essentially says, like, okay, even if our right edge only comes to here, we can actually tell it, even if you're within this space, let's extend the right limit to be, you know, 500 pixels further than whatever this is, which means you can have like an area that shows further but only triggers when you're within this spot. So that's the offset to do. And then we have a boundary disable. So the camera naturally has a vertical collision shape that follows like the edge. That way I don't have to like define world boundaries. The camera's limit will just naturally push that world boundary, but you can also disable the boundary. But yeah, and then as I mentioned, if you're inside of this space here, where you have this rectangle and then you also have this rectangle up here, the camera will look at both of them and say, okay, well, we're going to take the furthest limits from both of these rectangles. So when you're standing here, the left limit will be this rectangle here, but the right limit will be all the way over here, and the bottoms on both of them are the same, so it's going to be here. But the top limit, this one stops here, but this one comes all the way up here. So when you're standing here, you end up with like this huge like rectangular region. But it's okay because you can't actually see out here because you can't reach that far anyways. So this system works pretty good, and the only real thing that I disliked about it was that the camera code is like it's a bit complicated. There's a lot of yucky code in here. There was a few ways to do this, but I decided that this way was kind of the easiest, even though it takes like some ugly math to make it happen. So yeah, in our camera, in our process function, we have like a bunch of computations that we essentially run every frame. And from what I've read, according to the AI, it's not that performant heavy, so apparently it's fine. It doesn't seem to run slow, so I guess it's okay. But so we have some checks, like if there's not a follow target, then we just don't process anything. In Godot, you can make the camera a child of the player, and then the camera would just follow it automatically, but that precludes like any advanced camera logic. So the better way to go is to just let the camera live outside of the player and then manually tell the camera who to follow. So that's what we do here. in the game, we manually set the follow target, and then in our process function we basically just say, okay, wherever the player is, just set your position to where the player is. The camera natively has these limit properties that will define where the camera goes. But these limit properties work, like they work fine for limiting the camera, but they don't work fine in terms of movement logic. When you change the limit, if the camera is outside of it, it will just snap to the limit, which is essentially never what you want to happen. So in order to remedy this, what we have to do is use limit targets. So we have limit target right, limit target left, limit target top, limit target bottom. And these are this is where we want our limits to be. And then we have to have logic to update the camera's limits to move towards those targets. So the way the camera works is we have two things that are happening. First, every frame, we're moving the camera's limits towards the limit targets. Once they hit the limit target, they stop moving. And then the second piece of main logic here is that we have to, wherever the player is, we're constantly saying, okay, do we have new limit targets? So we'll jump into there first and show. So first, this is really easy. We get bounds for the target. So all we do is all of the reference recs are put into a group called camera bounds, which makes it really easy to just grab them all. You don't want to be traversing the node tree to do this type of stuff, because if you're doing it every single frame, that's going to be very slow. But the node group is a really good optimization to grab all of the nodes very quickly. I think it's probably like a big O1, like constant time lookup. So like you're doing a lot better by using a node group. And I think I don't even really need this, but I think it typecasts it. So yeah, it's fine. I don't think it actually costs anything in terms of performance. And then, so we're grabbing every single rect within the whole map or level that we're on, but we need to grab the rects that we're only intersecting with. And so we have this where statement which filters through all the rects that we have. So we have two checks that we do here, which is p.active, and active is just a Boolean. If you have multiple rooms in a level, we're just going to skip over any rectangles that aren't a part of the room that we're in. And then the more important one is we grab the rectangle, and then we're checking if our player's global position is a point inside of that rectangle. And so we just do that for every rectangle, and it's not really that bad in terms of performance. Apparently it goes really fast anyways, but there's maybe like 30 rectangles defining views within a level, so like this never really gets very big. But yeah, so we grab all the bounds, we grab all the rectangles that are valid bounds that we're overlapping, and then if we don't have any bounds, if this check returns nothing or it returns an empty list, we do nothing, which is just an optimization. Or if it returns a list of rectangles that is the same as what it had already been, we also do nothing, because there's no need to, update limit targets or do anything if nothing has changed. So that's our little optimization. If it has changed, then we update our bounds, and then after that we update our limit targets. And so that's what this does. It update limits is kind of where the crazy stuff happens. So we have this get union limits for bounds. It just, as I mentioned before, it looks at all the rectangles and finds the furthest bound of all the rectangles put together. And then we also grab priorities, which is, as I mentioned before, if the rectangle is too small, this essentially will just add the screen's width and height to whatever the priority limit is, just to like expand the bounds in that direction. And then so this is just the simple part, is after we grab the limit bounds, we update our limit targets. And then we have right here, we're just taking into account our priorities, which is what I was mentioning earlier, is like, okay, we just like add like our screen size to it, for the vertical and for the horizontal. I also have some logic in here that if the rectangles we're jumping between, like if we're in one rectangle, let me jump up here and grab an example. So let's say we're up here at this rectangle, this guy here. And then suddenly we jump down and we're in this guy here. So we have a check that says, if the new rectangles we have jumped between, if they are not overlapping at all, which we do this by checking the limit target. So like if our limit target is completely outside of what the original limit was, then we have probably done a room transition. In fact, there's not really any way to make such a drastic jump between camera bounds except teleporting between rooms. So if we're teleporting between rooms, then what the logic is that we don't even worry about moving the limits slowly. We just automatically move the real camera limits to those new limit targets. We have logic that will slowly, every frame, move the limits towards limit targets, which creates kind of like a smooth moving camera scroll. But when we're teleporting, we don't want like this scroll effect, because when we move from here to here, we don't want the camera to be like, oh, let's scroll down into view. We don't want that, because we don't want like to reveal anything on the map. We don't want to, it just looks janky. So when we're teleporting, the camera jumps instantly. We have a fade effect, so you can't actually see it. And so the camera just appears there. And so it kind of sells the effect that we're actually changing rooms and not teleporting in space. And then lastly, we have this calculate jump distances. So I just put this into its own function. It could have been here. But if we're not teleporting, we have a bunch of, let me go over here. A bunch of complicated logic that we need to use to create like a smooth scroll effect. When we move between these different rectangles, we basically need to calculate how far the limit is moving. When we go from this position here to this position here, suddenly our limit target is not here anymore. It is way up here. Initially, I would just automatically just go, okay, move from here up to here. And what that had the effect of doing was that if the limit jumped drastically, like if we were going from like this space here all the way up, or from like this space like all the way over here, like the larger the jump, the quicker the camera would scroll to that spot. And so like if the limit jumped a very small distance, the camera would just like crawl to it. But if the limit jumped like, 5,000 pixels, it would be such a large distance to jump that the camera would just fly, it would snap. It would look like it was snapping, which was the same thing as just not having a system at all. And so what we needed to do to remedy this was to say, okay, where is the camera's new limit target jumping in relation to the player? And so if the player's here and the limit's like way up there somewhere, instead of jumping to that spot way up there, what we really want to do is jump to the edge of the viewport, because the edge of the viewport is always going to kind of be a fixed distance from where the player is. And so by always jumping to the edge of the viewport rather than the edge of the viewport in relation to where the limit is, because for example down here, the edge of the viewport is here, but it could be higher if the limit had more space. So in the case that you cross this threshold and suddenly you do have more space, we need to find out where would this new edge of the viewport be now that we have like a greater limit to jump to. And so that's essentially what this logic does, is we're kind of figuring out where is that new edge of the viewport going to be, and then we're going to basically set a value that says, okay, like when we start scrolling the camera's limits to our new limit target, instead of jumping to that new target, we're gonna just instead try to jump to the new edge of the screen first. And then I have an optimization that says once we reach the edge of the screen, then you can just snap the rest of the way because it's outside of the viewport, so we're not actually going to see that movement anyways. And so here is the actual logic where we move. And essentially what it does is it moves us towards our limit target. Originally had this where it was like hard-coded for every single direction, but then I realized we could generalize it, and so I generalized it, which makes it harder to understand, but also easier to debug and easier to fix bugs once and not have to worry about them. So I'm not even going to try to explain it, but maybe we can try to explain it. So we have a bunch of checks we do. First, we're checking if our limit is at the target. If it's at the target, we do nothing. We just return the target because we're already good. And then we have this little check here that says, is the limit outside the view? So we have two cases that are happening. When we change between camera bound, we either have our limit target is either within the viewport or it's outside the viewport. That's always the case. We can never have anything different. So we're doing our check. We're saying, is the limit target outside of the viewport? If the limit target is outside the viewport, then the next thing we do is we check, is the current limit of the camera also outside the viewport? Like, are they both outside? And if they're both outside, that means we can't see them. So once again, we just snap to the target. It doesn't matter. But if the actual camera limit is in the viewport, then we need to scroll it slowly to whatever its new position is going to be. And so this is where that limit jump comes in. We're going to move our limit to whichever is closer, either the limit target or the screen edge. Then we just use this math move towards to basically move our target to the thing. And we're calling it current because we're just calculating a number, and eventually we just return it. And then here's the other case where the limit target is inside of the screen. So this is the case where our target is now within the viewport and the actual camera limit is outside the viewport, which means we're moving inwards. And so in this case, if we basically are just doing a check that's saying if the camera limit is outside of the viewport, first we're going to set it to inside of the viewport or to the screen's edge. This will also prevent the limit from flying at super fast speeds. We're always kind of using the edge of the screen as like our starting point to prevent the camera from speeding around. And then after that, then we just move towards the limit target and then we return it. And so that little piece of logic happens for all four limits. So yeah, that's the logic for the camera system. Maybe nobody wanted to know this, and that's fine, but maybe you're also a game dev and you're trying to work on this stuff. This is definitely the most devloggy I've gotten. I'm not really trying to do a devlog. This is more for the purposes of like demonstrating the game. I'm not trying to like talk about code. I don't think a lot of people are interested in code. But if you are, and maybe you find this technique interesting, you know, I've broken it down a little bit for you. And so let me demonstrate this once more. In here, we're in that one rectangle. I can even pull up Godot and show it. So that rectangle kind of defines what our bounds is here. And so you can see, like, if you look here, we can see up to this third line and just a little bit past it, which is what you'll see here. You can just see just a little bit past it. And so these screen bounds work really well. And one of the cool effects of it is that, as I had mentioned before, the original issue is if I want to move this room, I want that target to stay up to date. If I move this room somewhere else, I don't want to have to fuss with that camera view. I want things to remain as they were. And so that works fine because of that. Oh, and I killed my player, I think, because I moved. And then when we go back through here, you can see, okay, like we're back on the other side of it now. And so let me demonstrate that whole threshold piece. So on the original, let's go back to the original map. I actually put this ledge here just to test the camera scrolling. So when we stand here, if we just scrolled straight to this limit, the camera would fly. So instead, we're grabbing the edge of the screen, which is right here, and the limit's gonna go, okay, we're gonna start from here, and then we're gonna slowly scroll up, and the new limit will, see, so the new screen edge is right here. So instead of scrolling our limit from this spot all the way up to the spot, all the way up to the top, we only scroll it just to here. And as soon as that top limit hits this area, it snaps the rest of the way. Because there are some cases where you can be jumping up and maybe you're moving faster than the camera is scrolling. And so you can end up like beating the limit up to the top, and the screen will kind of like slowly scroll up and it feels weird. So the camera moves very quickly up to that spot and then goes the rest of the way. And this seems to work pretty well. There are some cases where the camera can like scroll a little harshly. Like if you like back and forth, like it can get pretty jarring. But for the most part, this is not the way people play games. People don't just like sit here and go like, hey, let me test the camera. So like when you're actually playing, it's fine. Like the camera scrolls pretty smoothly and you know, it feels good. See, when we're here, we have this whole right limit, but as we scroll down, you're gonna see when we lose that and the limit shifts just a little bit. So in practice, like, it's felt pretty good and I haven't had any issues with it. Going back to the first level, it feels a lot better to not see past the edge of the screen and for the ground to stop here instead of going beneath it where you can see like background again. It just gives you the effect that the game feels a lot more put together. See, like we can't see like the top edges of things. You can actually see if we jump over here, it does kind of like jump up a little bit, but it's okay. I was okay with that happening. But like, it keeps the world feeling a lot more cohesive. See, we can't even see past this wall. Whereas without the proper camera system, you can see past this wall. But as soon as we jump down here, it scrolls over and now we can see a little bit. See, and you come over here and you can't see any further than this. This is as far as the camera lets you see, which is good because we don't want to see outside the level. It cheapens the game. And see, now as we run over here, we can't see past this side wall. When we're down here, we can run past that sidewall, but as soon as we reach this area, we can't. And it just makes the game feel better. And since when we're up here, we're not showing you below this part of the screen. Like this is the new bottom of the level now. It just feels a lot better. See, even as we get from here to here, the camera scrolls up a little bit. It feels nice. So even though like the code is a bit ugly, and now that we're up here, we cannot see beneath anymore. It makes the world feel more polished, more directed. And so even though the code is very horrific, overall I'm really happy with the result, and it's made the level design experience a lot better for me, and I think it just is going to make for a more immersive game experience. So yeah, that's basically it for the camera system. I hope that it was interesting, entertaining, or whatever. Hopefully it gave you some happiness or something. But yeah, that's it for now. I hope that you guys enjoyed this video, and stay tuned for more Blast Project updates.